Hello, let's continue our Sudoku adventure with Cool Zip by Flinty. This continues our thermometer theme week, so every puzzle this week will involve thermometers in some way, along with another constraint. So today is thermometer and zipper lines, and don't worry, I will go over the rules. So we do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have thermometers in the grid. We basically have, that's here and here. It's basically two overlapping thermometers that share the same bulb. So the way thermometers work is as you move away from the bulb, the digits have to strictly increase. So if this was, say, a 1, this needs to be bigger than 1. Could be a 2, it could be a 3. You can skip digits if you want, as long as you get bigger as you go. Now this couldn't be a 2, because 2 is smaller than 3. This has to get bigger than 3. So we could do, say, 5, 6 if we wanted to. And then now this one also has to be bigger than 1. So we could go like 2, and then 4, and then 5. So this would be one way to fill these two thermometers. There's probably other ways. All right, in addition to that, we do have a zipper line, and the zipper line's been styled to look like a thermometer just for aesthetic purposes, but this is a zipper line and not a thermometer. So what the zipper line does is whatever the central digit is, say it's 5. What that means is all of the cells that are equidistant from each other, away from that center, sum to the center value. So this could be, say, 4 and 1, because 1 plus 4 is 5. Then these two would also sum to 5, so maybe 3 and 2. And then these two would also sum to 5. So maybe 1, 4, like that. So this would be one way to fill this zipper line. Because that adds to 5, that adds to 5, and that adds to 5. And the 5 is the center digit. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I don't know if I want to think about I think I want to think about both of them, but anyway, this thermo we'll start with. So this has to be smaller than at least 4 digits. So if this was 6, 5, and none of those digits are 6. So we can put 5, 4, 3, 2 in here. And in fact, since none of the digits are 6, we can place the 6 here. Because 6 can only be at the end of a thermo. If I try to put a 6 here, this would have to be 7, and there's no 7 in the puzzle, right? The biggest digit cannot go on any of these cells. So this is a 6. And that means that this is going to be 5, 4, 3, 2, and this has to be a 1. Which means the 2 is definitely surrounding the 1 somewhere. But we don't know exactly where it is, but it's in one of these two. And then from there, it's a little bit fuzzy. But what we can do is we can try to pencil this puzzle. So pencil the thermos. So, because we could go 2, 3, 4 even. Maybe we don't pencil the thermo yet. Let's think about the zipper line next. So one thing we can do with this zipper line, right? We know there's no 6 other than the center, we cannot put a 6, right? If I tried to put a 6, say, here, then this and this digit add up to this digit, but 6 is already too big. I'd have to do 6, 0, and then another 6. There's so many problems with that. So these can't be 6. So the 6 is placed here. None of these can be 6, so the 6 is placed here. And then that makes our sum 6. Nice, because this can't be 6 either. All right, so 6 ends up over here somewhere. And 6 is not here, so 6 ends up one of these two. So this is not a 6 anymore. So we could go 5, 4, 3. So this is 2, 3, 3, 4, 4, 5. We could fill that. We know these all add to 6, which means they do not involve a 3. Because these, we can't repeat the 3 here, we can't repeat the 3 here, and we can't repeat the 3 like this, right? So if 3 is not on any of these, then the 3 for this column goes here. And 3 is not here either. So this 3 looks down, this isn't 3. So that places the 3 here. And these 3s look in, putting a 3 in one of these two. And so now we know none of these involve the 2. So if we want to do 2, 4, the 2 is up here. I'm not sure if that's important yet. What we can say is this is either a 1, 5 pair, or it's 2, 4 with a 4 here and a 2 here. These are from 1, 2, 4, 5, but I don't know. I guess I could put 1, 4, 5 in just for the rest of this box. And then, so since we can't put a 2 down here, we can't put a 4 up here. So these are 1, 2, 5. What else can I say about this? This column is 1, 4, 5. That's not a 1. What else can I do here? Maybe it's this row, because we have this thermo here. because this is an escape hatch. This can be anything is the problem. Maybe it's this thermo then. We go 6, 5, 4. So this is 2, 3, 4, but it can't be a 3. And then this is 3, 4, 5, and then this is 4, 5, 6. We do anything with that? Not really. The 3 in this row is in one of these two, I guess. The 3 in this row is in one of these two. Aha. So this is a tough spot, but where's 3 in this column? Right, I noticed that these 3s line up in these boxes. So 3 in this column, this 3 says not here. This can't be 3 because of the thermo. This can't be 3 because of the 3 in the row. And this can't be 3 because of the thermo. So 3 ends up in one of these two. Well, if in this column 3 is in one of these two, no matter where it is, it'll be in this box. So that claims the box, making this have to be a 2. And now this is 4. We get our 3 here, going slowly. This is 5 and 6. So these can't be 6s. That places the 6, the final 6. This 4 says this isn't 4, which means that's not 2. This isn't 5, which means that's not 1. This isn't 5, which means that's not 1. Okay, 1, 4 pair means that this is 5. 5 has to go with 1. That means this is 2, 4, and this is 5, 1. Nice. Puts a 4 there. This cleans up. This is the 1 for the column, and this is a 4. This is a pair. It's 2, 3, and the 2 tells us the order. That's 3. Oops, that's 3, that's 2. Places the 3 there. This 3 got placed a bit ago. We get a deet deet doot in the corner. Nice. This is a 1, 2 pair. This is a 4, 5 pair. We know the order, 5 and 4. That's 4 and 5. 1 in this box goes here, resolving the 2 and the 1. And up here we need 2 and 5, like that. And we're done. Wow, that was neat. I like the sort of bracket aesthetic here. It's pretty neat. Really interesting logic as well. So thanks, Flinty. I liked the 2 getting. Oh, no, it was the 3 getting restricted in this column to these two cells. You can see it ended up here. That was a tough spot, but being able to pencil the 3s here and here helped spot that. So it's a neat trick for you if you haven't seen that before. Some might call it an X-Wing. I would not. I'd say an X-Wing requires 4 boxes, not 2. But I called it claiming in column 2. So either way, gets the same result, and it's fun. So I hope you enjoyed this as well. And if you did, then why not leave a like, subscribe, and a kind comment below.